NEET 2018 paper. If your basics are strong, you can get answers in seconds. Make sure that you work on your basics. Let us solve this using shortcut, and after that the explanation to get the final answer among these four. Okay. An object is placed at a distance of 40 cm from a concave mirror. So this is concave mirror, principal axis. Focal length is 15 cm. So this is focus, 15 cm. Hope you understood. Distance from the pole. If the object is displaced and the object distance is 40 cm. This is focal length. This is center of curvature. Here is the object. Here is the object. Object initial position. This is at a distance 40 cm. Center of curvature is 30 cm. Now, if the object is displaced through a distance of 20 cm towards the mirror from here to here, this is object final position. Now, observe the displacement of the image will be. We have to find image. If this is the object, this object is beyond C. If the object is beyond C, image will be closer to the mirror, somewhere here. So this is I for image, initial image. Initial image. For initial object, this is the initial image. Now, because of this object in the final position, this object is between C and F. If it is between C and F, then we get magnified image. So this is image for the final position, IF. Image I for the final position. See, the image is displaced away from the mirror. So towards, away. And observe the values 40, 30, 15. Object distance, focal length is 15. Object distance is 40. Object distance is 20. So by this, certainly we won't get numbers like this, 30. So it should be B. Because the formula is 1 by V plus 1 by U equal to 1 by F. Right? So that's why it should be 36 away from the mirror. And based on the concepts that we have learnt, recall 5 diagrams that you used to draw with respect to a mirror. Mirror, if object is close to the mirror within F, object at F, object between F and C, object at C, object beyond C. Same concept. Now, let us solve how to get this. Mirror formula is 1 by V plus 1 by U equal to 1 by F. So first case, object distance is 40. We have to find image. Object distance is 40 minus 40, because with respect to this pole, distance is to the left. Cartesian sign convention, Cartesian coordinate system. To the left means negative sign, minus 40. 1 by V equal to 1 by F. Focal length is 15. That is to the left. 1 by minus 15. So bring this to the other side. 1 by V equal to 1 by minus 15. Minus becomes plus, 1 by 40. Take 5 common factor. 1 by 5 minus 1 by 3 plus 1 by 8. 8, 3 minus 5 by 3, 8 equal to 1 into 1 by 5 equal to 1 by V. Now 5 gone, V equal to 83 into more 24 minus 24 centimeter. So this is image. This distance is 24 centimeter. Minus means it is to the left. Now first half is over. Next, this is final position of the object. Now object distance is 20 centimeter. This is 40. Displacement is 20. Remaining is 20. So again, this formula 1 by v wanted. Let me substitute here. No, let me substitute here. 1 by v equal to 1 by focal length minus 15 plus 1 by 20. Hope you understood. So this distance is minus 20, because of all this becomes plus 20. 20 minus 15, 20 minus 15 is 5 by minus 15, 20. 5 1, 5 3, 4 3, 60. So v equal to minus 60 centimeter. This is initial final image distance, initial image distance, final image distance. Difference of these two is minus 36. Minus sign means away, using mirror formula and without using formula. Isn't it amazing? Yes. Please work on your basics. Trust your basics. Students, for more such shortcuts and explanation, download RClass from Google Play. Then find courses on CET PYQ and NEET PYQ. Subscribe them and get amazed with the content as well as the price. Start your. A beam of light from a source L is incident normally on a plane mirror fixed at a certain distance x from the source. The beam is reflected back on a spot on a scale placed just above the source L. When the mirror is rotated through a small angle theta, the spot of the light is found to move through a distance y on the scale. The angle theta is given by. So this is a basic from reflection from a plane mirror. Few concepts are involved. Let me explain that. This is a plane mirror. This is the object. Light from the object is incident normally, then reflected light reaches. So the arrangement is such that the reflected spot lies just above the object. So this is the object and this is the image. Because a scale is placed something like this, image reflected light is obtained just above the, not image, reflected spot is obtained just above the source. This is first concept. Normal incidence, normal reflection. Angle of incidence is 0, angle of reflection is 0. No deviation. Of course, deviation is 180 degree. Means there is no lateral deviation. Done. Now, the beam is reflected back onto this spot on a scale placed just above the, when the mirror is rotated through a small angle theta. This is second concept. This is the incident light. If this is the mirror is turned by some angle. So this is normal. This is normal drawn to the mirror. When this angle is theta, there is reflected light such that the total reflection is 2 theta. With respect to this, if the mirror is turned by 30 degree, then the reflected light is obtained at 60 degree. If mirror is turned by 10 degree, reflected light is obtained at 20 degree, 2 times. Okay. So if theta is the rotation given to the mirror, then 2 theta is the direction of reflected light. This is second concept. Now I want some space. This is the mirror. Beam of light source L. So this distance is L, fixed at a certain distance x from the source. So this is x. When it is turned by theta, the mirror is turned by theta, the reflected light will be turned by, this is reflected light, turned by 2 theta, this concept. Y is the distance on the scale. So this is the reflected spot, incident, reflected, reflected spot. So this distance is y. So using those two concepts, basic concepts, we can draw this, and the remaining is very simple. See, the angle theta is given by, and moreover concentrate on theta. It's beautifully crafted, problem is beautifully crafted. When the mirror is rotated through a small angle theta means sin theta is approximately equal to theta, tan theta is approximately equal to theta. Good. Now with respect to this angle, opposite adjacent means tan theta. So tangent of 2 theta equal to y by x. For small angles, tan theta is approximately equal to theta. Therefore theta equal to, bring 2 to the other side, it is 2x. Y by 2x. Not that it is a difficult question, but small concepts are involved. We have to go through, or we have to understand and pick the concepts correctly one after the other. After that, we can get the final answer. Match the corresponding entries of column 1 and column 2. Column 1, magnification. Column 2, convex, concave, real, virtual. And then these are the options, A, B, C, D. Now consider A. Magnification is -2. Magnification, minus means inverted. Inverted image is always obtained for concave mirror. So this is for always concave mirror. Convex, it is always erect and virtual. Inverted, and this is real. So inverted, real and concave. See, A is Q and R. A is Q and R. So this is the answer. It looks really scary because we think that we have to check all the possibilities. But if you start from 1, then you can easily pick, because A has few options, B also has, C and D. Since this is matching, none of them are matching, so they should be the answer. Hope you understood. Again, minus means inverted. 2 means magnified. Magnified is always obtained by concave mirror. Since it is inverted is always real. So that's why inverted real, QR. This is the answer. 2 plane mirrors are inclined at 70 degrees. A ray incident on one mirror at an angle theta after reflection falls on the second mirror and is reflected from there parallel to first mirror. Fine. The value of theta. Again, this looks very confusing and scary problem. Understand? In ray optics, try to draw simple diagram and use all the concepts that are given in the problem and analyze thoroughly. You'll get the answer. Now, there are 2 plane mirrors. and they make an angle 70 degree. So this is first mirror, this is second mirror. Let me not shade the mirrors, okay? And this angle is 70 degree. After reflection from the second mirror, or after reflection falls on the second mirror and is reflected there parallel to first mirror. So this is the reflected light. Final reflected light. It is given, this is parallel to this mirror. Then draw normal. Normal. This should be the incident light. If this is incident, then draw normal here. Then this is the incident light. Say first incident light, this angle is theta, then this angle is theta, angle of incidence, angle of reflection. Then this reflected light falls on the second mirror, gets reflected such that this is parallel to this. Fine. If this is parallel to this angle is 70, then even this angle should be 70, isn't it? So this is 70. This is normal. Normal to this means this angle should be equal to 20. Then this angle is 20. This angle is 70. This is already 70. This is 70. This is 70. 140. Then this angle is 180 minus 140 is 40. If this angle is 40, then this angle, because this is the normal, one angle is 40, the other one is 50. If this is 50, this should be 50. It is 50 degree. Thoroughly understand the problem. According to that, construct the diagram. Remaining is high school mathematics, isn't it? A rod of length 10 cm lies along the principal axis of a concave mirror of focal length. Concave mirror of focal length 10 cm. Such a way that its end closer to the pole is 20 cm away. Understand the statement. Construct the diagram. This is a mirror. Focal length, focus, focal length is 10 cm, of course, centimeter, let me not write. This is C, center of curvature, 10, this is 20. Now, rod of length 10 cm, rod of length 10 cm is placed such that its end closer to the pole is 20 cm away from the mirror. So, this is the rod. End is 20 cm away. So this is the pole. Of course, mirror, let us not shade the mirror. Understand and solve. See, this end is at C. So after reflection, it will be at C only. Let me use green for image. So there is image here. That end will be there only. Now this end is beyond C. This end is beyond C means image should be closer to the mirror. So the image of the rod looks like this. Of course, we are not worried about thickness of the rod. This is one end of the rod, A, B. A will be there only, but B appears to be here. A is A dash, B is B dash. Okay. The length of the image. Fine. Observe the options. If this is 10 centimeter, this cannot be 10 centimeter. 2.5 centimeter, 5 centimeter, 15 centimeter. It could be anything. So let us use mirror formula, but only for position B, end B, because A is at A only. So we have to find B. This distance is 20. This is 10. Therefore, object distance in our calculation, object distance is 30 centimeter. We have to find image distance, and focal length is 10 centimeter. 1 by V plus 1 by U equal to 1 by F. 1 by U, 1 by U, 1 by U is minus 30, students. Why minus? From the pole to the left, minus. 1 by V equal to 1 by, again, focus is to the left of the pole, to the left, minus 10. Now this comes to this side, minus 1 by 10 plus 1 by 30 equal to 1 by V. Minus 30 plus 10 minus 20, 10, 30. 0, 0 gone. This is 1 by V. Therefore, V equal to 30 by 2 minus 15 centimeter. So, this distance is 15 centimeter. This is 15. This is 20. So, this length is 5 centimeter. 5 centimeter. So, if this is the rod, then image appears to be here. See, image appears to be here, and total length of the image is less than the object. Object length is 10 centimeter, image is 5 centimeter. Not this length, this length.